So, hello. Thank you so much, first of all, for inviting me to this NDSML Summit. And I'm super happy to be a part of it. I'll be talking about the link between our minds and AI. So, why should you listen to me, right? So, I'm the head of AI at Earthbanc currently, and also the content curation and community engagement lead at Airplane Alliance. And I have a background in research on computational neuroscience at KTH, Royal Institute of Technology. My hobbies are shooting, and I'm really good at it, traveling, and learning anything new. So, AI holds a huge promise to help us understand, predict, and classify complex mental health disorders. So, AI is closely linked to human psychology, and the basis for research in the field stems from the network of neurons in the human brain. The neurons make connections based on the perception and outside stimuli and transmit the information through electric and chemical signals, allowing the adaptive learning to take place. So, AI finds its primary objective in emulating human neurological functions, which is basically mimicking the way rational human thinking or human cognitive works. So, given this, its complexity and scope are increasing rapidly today. So, for context awareness, mechanisms bring out an ability to think and create like humans to natural language processing, which gives AI a platform and method to communicate. So every step seems to be taken in the direction of making it wholly analogous to human functioning and thinking. So, in my opinion, AI can help reduce the stigma around mental health disparities. So, if AI is used cautiously and correctly, it's very promising to understand the complex mental health diseases and even transforming mental health care. So, AI can be very beneficial in predicting and classifying mental health disorders. It can also help subgroup them based on mood disorders, anxiety disorders, or if they're co occurring, which is often the case. So, someone who's going through an anxiety disorder like depression is most likely to also have a mood disorder like borderline personality disorder, etc. So, AI can also potentially achieve high accuracy as we keep developing more robust and advanced techniques. And it will be possible to help mental health practitioners to redefine mental health illnesses more objectively than currently done in DSM 5. So, and also to identify these illnesses at a much more earlier or prodromal stage when the interventions may be more effective and personalize the treatments based on individuals' unique characteristics. Obviously, this needs to be done with a lot of caution and a lot of research is required for the same. So, but I believe that the amalgamation of AI into identifying mental health illnesses could also reduce the stigma surrounding it, as it is still an issue and it's frowned upon in a lot of parts of the world. Like, I originally come from India, which is a developing economy, and mental health disorders aren't as accepted as it should be. So when we use advanced neuroscience tools using AI, it might be sought after as a more acceptable illness, as it's something closer to a physical diagnosis. So next is AI and neuroscience and how they could basically mutually benefit from each other. And I'll stress about it in the next slides. So what are the biggest opportunities for AI in neuroscience? So in my experience, one of the biggest opportunities for AI in neuroscience is doing more biologically plausible research and creating a visual perception of unique features of human cognition. This will lead us in understanding and knowing so much more about the human brain, which is still a mystery to a huge extent. This will eventually lead us to understand mental health illnesses, triggers to mental health illnesses, and the best way to recover from them. Basically, biologically inspired artificial neural networks and computational neuroscience approaches that attempt to elucidate human brain networks are gradually getting closer to the experimental neuroscience at this point. And however, this would definitely require a lot of research and a lot more conversations between neuroscientists and AI researchers. It's very fascinating how both can learn from each other and develop from each other. So, neuroscience has always been a key inspiration behind the history and development of artificial intelligence. And of course, there's so much to still learn from it. Neuroscience has always been an inspiration to make the network more intelligent and more human like. So, there are two key points to it. One is that artificial neural networks try to replicate or imitate human intelligence. Now, with ideas comes a structure in which you can envelope the idea. And the second key point is artificial neural networks tend to mimic the brain structure. So the transformations made using AI are breaking the internet nowadays. We hear how reliable and accurate AI is getting, and however, it still has a lot to learn from our brain or neuroscience. As AI is inspired by the structure of the human brain, so are the neurons in the neural networks. The neural networks have very similar characteristics when compared to the biological neurons in the human brain. So the basic working mechanism is that when a neuron gets activated, it generates a spike and sends a signal to other neurons. In artificial neural networks, when we have interconnected neurons, when a neuron receives an output, it gets activated and passes on the information to other neurons. So it works very similarly to how a human brain does. In a simple example, we can keep getting better at a task we perform in real life. In a similar way, we train the AI with a lot of data. The artificial neural network has X number of connections, and each connection on the neural network is associated with a weight. So the weight decides how much influence the input will have on the output. So, and the biases are constant, and an additional layer into the next layer that will always have the value of 1. So during the training process, we tune the weight from node X to node Y as required. However, there's a lot about the plasticity and the malleability of the human brain and try and implement them into AI networks. It's ongoing research to make AI more human-like. For example, as a human, I can walk even with my eyes closed, but the AI model to do the same task in a new environment, which is walking with eyes closed, will probably not work so well. So the next is how can neuroscience benefit from AI? So, as we all know, brains are far too complex for us to understand at present. I read a book called The Psychopath Inside by James Fallon, who's a neuroscientist himself, where he explains brains in terms of a 3x3 Rubik's Cube. It's so impossibly difficult to understand and visualize without prior knowledge. This is where AI jumps in, according to me, and can be employed in a number of ways, where AI can be used to produce new tools or applications to come up with connections or general theoretical principles. So, this will help us understand the complex machine that our brain is. And on a more logical level, AI can help us visualize the different patterns in the brain and try to find the underlying reason for the difference in patterns, as well as analyze the effects. For example, certain types of overlapping in the human brain cause people to lose memory for a short duration. So this can be visualized and studied using RNNs, recurrent neural networks, which I worked on during my bachelor thesis. So the next is the state of mental health, which is a big thing right now, according to me. Mental health is the number one global disability. Around 450 million people constantly suffer from such conditions, facing mental health disorders among the leading cause of ill health and disability worldwide. It's one of the most stigmatized and hidden disabilities, and 75% of the people who are going through a mental health disparity do not seek any help they need. So, on an average, mental health disability costs over 1 trillion US dollars every year and is lost in productivity. These numbers show a perspective on mental health, and these numbers are from 2019. Also, since 2019, we are in a global pandemic, which undoubtedly has made these mental health issues a lot worse. Lockdown, the fear of the unknown, social distancing that impacts our relationships, our financial crisis are summing up to increased anxiety, depression, bipolar disorder, or PTSD. Significant barriers exist to getting care. Chief among them are long-standing stigma around mental health, and but there's still even more to the dire reality as recent events push more people to the brink. There simply aren't enough clinicians or specialists to treat everyone who needs help. So 2020 was not our best year, but on the other hand, we have entered a fascinating era for mental health and behavioral health care. Advances in AI make it possible to build intelligent systems that enhance the quality, accessibility, and efficiency of care while also providing entirely new opportunities. So, AI solutions for mental health. There are many ways in which machine learning can help us understand better and possibly treat various health conditions. The mental and behavioral healthcare fields are also benefiting from advancements in AI. So, where are we now? Where and how AI is helping to tackle these mental health issues? So I'll proceed with these 5 points that I have written here. The first would be image analysis. So machine learning and deep learning techniques work best when we can train them on vast physical data sets. Therefore, we can see already a significant shift in medical image processing supported by AI, detecting liaisons, tumors, and tissue abnormalities in X-rays, CT, or PET scans. It's not only a way image processing can help. So for mental health disorders, AI can also track different signaling pathways and abnormal network activities and aid medical image interpretation. A great example of how machine learning supports mental health treatment is in early diagnosis or detection of Alzheimer's disease. So, researchers at the University of California show that a simple PET scan powered with ML can detect Alzheimer's 6 years before a definitive diagnosis that is based on this early stage irreversible clinical symptoms. Also, a study from Carnegie Mellon University and University of Pittsburgh shows how to identify suicidal individuals by analyzing the alternations in how brain patterns represent certain death-related concepts. The model accurately distinguished people who have attempted to take their lives with 94% accuracy. Researchers are continuously developing and advancing this research to apply their findings to a much larger sample and then use to predict future suicides. And next would be chatbots and conversational agents for cognitive behavioral therapy. So another use case for incorporating AI into mental health sector are chatbots. So the integration of natural language processing and virtual reality has allowed us to create interactive, intelligent virtual humans that can provide daily consultation and simplified therapy. So mental health chatbots continue to improve with natural language processing and deep learning, and they provide thoughtful assessment options to determine the severity of mental health illnesses and an opportunity to fight with daily anxieties and when they are still possible to harness without medication or professional help. As AI techniques continue to be retrained, refined, and improved, it may be possible to identify mental health illnesses at earlier or pre-traumal stage when interventions may be more effective and tailor prescribed treatments based on individuals' unique typing characteristics, as I also mentioned in the beginning. So the next would be voice recognition, image recognition, and text analysis for prediction, monitoring, and prevention. So we already know that people's behavior changes, and it does on many levels when they shift towards suicidal or self-harm crisis. So our phones and apps can track various data points to determine if a user is at risk. To identify users in emotional distress, Facebook looks out for worrying patterns with text analysis and posts and comments, users and friends. So researchers from Facebook FAIR project expand the study to include facial expressions for images and video posts to identify people in distress. IBM research couples machine learning techniques to focus on voice recognition and analysis from psychiatric interviews. Their models find verbal speech patterns to help clinicians accurately predict and monitor psychosis, schizophrenia, mania, and depression. AI algorithms can be used to harness and draw meaning from broad and varied data sources comprehensively. They give the power to analyze individual behavior and offer the technology to monitor treatment process and medication. What's more, they also enable to understand better the population prevalence of mental diseases, uncover the biological mechanisms or risk protective factors, and create the treatment processes and medication more uh, customized to the individual. So the next would be a conversational interface for daily support. So Amygdala is a mobile app designed to help people better manage their mental health by translating evidence-based cognitive behavioral therapy to technology-delivered interventions. Amygdala is a friendly conversation interface that allows people to track their daily activities and habits and learn and implement concrete coping skills to manage adverse effects and emotions better. Our AI-based chatbot, like they hold a conversation and determine the user's current feelings and recommends coping mechanisms. So, this app, Amygdala, aims to provide holistic support to the user to foster statistically and clinically significant improvements in depression, anxiety, and coping skill use. Routine is an essential part of the therapy. That is why it's created and has a dedicated section to better plan and execute daily habits, including medication intake. So these exercises help users to find their inner peace and immediately overcome anxiety through a breathwork medication and easy to follow physical exercises. The other one would be a helping hand for clinicians, which is very important right now because a lot of people who work in healthcare often report being burnt out, which isn't a good thing. Like it's a lot of burden for them. So well-trained medical mental health specialists are inadequate in supply. Their time is progressively limited, and mental health care needs to grow. And even if you do get the support of a specialist, it's rare to get that on a daily basis. So physicians are burdened with increased documentations, requirements, inefficient technologies. So these problems are incredibly cumbersome for mental health practitioners who must rely on their uniquely human skills in order to foster therapeutic support. So, research and development of technologies based on mental health resources continue to improve these apps and are not intended to replace the clinical treatment of any mental health condition. This fact came out loud during the dedicated AI design sprint workshops, and that is why it's decided by the Amygdala app to streamline and the cooperation between patients and specialists. So AI can deliver remote therapeutic sessions so crucial in social distant world and helpful for people who previously have had to travel and or take long commutes to get to their specialist. So that would be like a few important use cases. So anxiety and AI, which is an important topic. So although we feel fear at some point in our lives, not everyone experiences the overwhelming loss of control when anxiety takes hold of their life. So, take social anxiety, for example. For some people, the social anxiety becomes so unbearable that their life becomes disorganized and they avoid social interactions at all. So they stop hanging out with friends or trying to meet people. Things like dating or going to a job interview may feel impossible to them. Even smaller interactions, such as checking out at a grocery store or ordering food at a restaurant, can feel like unbearable tasks for someone with social anxiety, and it truly affects their life. So, treatments for anxiety disorders typically include psychotherapy, medication, and alternate therapies. But research by the Anxiety and Depression Association of America found that just 37% of the adults in US receive treatment. So, cost, availability, location, they are major hurdles in getting help. So, some students and low-income patients may find it hard to afford talk therapy, which starts at $100 for a 50-minute session. So there are, of course, alternatives to conventional therapeutic approaches. Apps and software tools have been around for years that aid the diagnosis and treatment for anxiety. But could artificial intelligence really replace your therapist? Let's see that. So, anxiety roots from amygdala, and amygdala is a complex system, a complex part of the brain. So, studies have helped us learn so much about the parts of the brain that control our emotional and behavioral responses. So, brain research has helped us label various parts of the brain and understand how they function alone or in connection with one another. So, amygdala is the part of the brain most closely associated with the fear response or the fight or flight. So, amygdala is a part of the brain limbic system, and the word amygdala means almond. So, this part of the brain was aptly named for its almond shape. And the amygdala is a collection of nuclei which are found in the temporal lobe. In general sense, it plays a strong role in the way we display our emotions. It has several functions, but it's best known for its function in helping our bodies process fear by initiating a flight or fight response to dangerous or threatening situations. So, anxiety and AI. How could AI help us control anxiety? So, this is a very important question here as we proceed towards understanding the role of AI in anxiety disorders or towards anxiety in general. So, fast and accurate diagnosis using AI is possible. A quick search online reveals that 2019 has seen a bit of surge in AI technologies aimed at diagnosis of anxiety disorders. So earlier this year, scientists at the University of Vermont proposed a wearable sensor that monitors the presence of internalizing disorders, which is a group of disorders that involves anxiety. If left untreated, childhood internalizing disorders predict later health problems, including substance abuse, development of comorbid psychopathology, increased risk of suicide, and substantial functional impairment. So, because of the long term outcomes, because they could be so severe, early diagnosis is important. So, children can get the help they need faster. Traditionally, researchers monitor children's behavior and responses to take certain tasks designed to diagnose anxiety and depression. Not only is the process slow, but it's also less accurate. So when UOV researchers tested the wearable sensor with 63 children, they noticed that the diagnosis was more accurate compared to the parents reporting their children's symptoms. But what's even more impressive is the speed at which the disorders can be identified thanks to AI. So the algorithm predicted anxiety and depression within 20 seconds. Something that we usually do with weeks of training and months of coding can be done within a few minutes with these instruments. So that's like a huge improvement. The team is still finalizing the tracker, but the initial findings are encouraging. Soon, children could be routinely screened for internalizing disorders. Also, in New York, Charles R. Mammer, who's a psychiatrist and a researcher at the Department of Psychiatry in New York University School of Medicine, has been studying AI and how it could be used to detect post traumatic stress disorder, which is PTSD, in war veterans. So, around 70% of adults in the US have experienced PTSD at some point in their lives. Traditional diagnosis is based on people filling out questionnaires. The problem with self reported diagnosis is it's full of bias, and symptoms are often underreported or overreported. So, to develop a more objective assessment, the psychiatrist and his team has an idea to analyze speech to evaluate speakers' emotional state. So they fed voice software created by the team invented Siri, Apple's voice assistant, a range of speech-based features. Then they used a machine learning algorithm, random forest, to classify the speech tone linked to the changes in the brain function. Speech showed to be a valuable predictor of PTSD. So the software analyzes words in combination with frequency, rhythm, tone, and articulatory characteristics of speech. So to infer the state of the speaker, including emotion, sentiment, cognition, health, mental health, communication quality, it's a lot easier and faster to accurately predict PTSD. So another thing is therapeutic AI approaches for anxiety disorders. So once the patients receive a diagnosis, they may be referred to a therapist or receive medication. But getting treatment can be a challenge. There is a hidden disorder, and many patients find it difficult to communicate their struggle to their healthcare providers. So, thousands upon thousands of individuals end up not receiving adequate treatment. Of those who do get the adequate treatment, are most often offered drug therapy, and the drug therapy often leads to horrible withdrawal symptoms. So, for some patients, long wait times are the difference between feeling anxious and feeling suicidal. Often, and especially like a research from UK, which I came across, the access to therapy is stifled by costs and accessibility. Computer and app-assisted therapeutic tools have often been around for years, but until recently, it was unclear that they could have made any difference. So, could speaking to a bot, help us heal? It's something researchers at Northwestern University, US, have been asking themselves. So, they put an AI system to test called TESS, the Integrative Psychological AI designed by X2AI Inclusive Communications. So it communicates with users who feel distress, whether they're having an anxiety attack or would like to talk to someone. Tess is available for immediate support, combining emotional algorithms with machine learning to analyze language, and AI can be assessed through Facebook Messenger or other third-party technology integrations to ensure that people get help which is adequate and is maintained by mental health experts. So TESS seems to be making a difference. When students were given unlimited access to TESS for 2 to 4 weeks, they said they felt less anxious compared to students who were not using TESS. So admittedly, talking to a bot may seem weird when we're used to expressing our emotions face to face. We associate I see indifference with automated chatbots, but most people appear to be accepting of the cognitive behavioral therapy, the CBT, delivered by a computer. What's more, we seem to find it easier to open up to an app than to a psychologist because we are humans and we are scared of the fear of judgment. However, Tess isn't the only bot available for immediate emotional support. There's the SU bot developed by USAI, which is aimed at people undergoing significant life changes and those with suicidal thoughts. So these could be some pretty good use cases, pretty interesting and helpful. So the next I would like to talk about empathy and AI. So as we know, like, we are humans, and humanity thrives on empathy. So, and the most important thing that humans like to feel, or something that will get AI closer to humanity, AI closer to a human minds or humanity, is definitely empathy. So in its early days, for AI in the diagnosis and treatment for anxiety, these are difficult tasks that a patient is different. Personalized therapies are must. So when we talk about artificial empathy, or empathy in AI, or computational empathy, which basically essentially is the same thing. It's the development of AI systems which can detect and respond to human emotions in an empathetic way. So, empathy is the ability to understand or feel what the other person is experiencing by putting oneself in the other person's shoes or position. And it can be of different types. One might ask if it's encouraging or terrifying. I would say, even though such a technology can be initially perceived as threatening by many people, it has some very interesting use cases in the healthcare sector. So, from a caregiver perspective, for instance, caring for mental health patients is emotionally difficult for nurses and doctors, and they often report feeling burnt out performing emotional labor above and beyond the requirements of paid labor, which compromises the quality of care. So, AI robots, which I mentioned before this, can use empathy to care for dementia patients without feeling burnt out, for example. AI robots can use empathy to take care of dementia patients without being burnt out. They can go between doctors and nurses and their patients. They can work closely with the doctors to gather more information and refine the treatment plans. So they often work with nurses to monitor patients and engage in day-to-day care. At the same time, dementia patients who receive consistent empathetic care report better outcomes. Also, according to the emotional intelligence pyramid, which is shown right here, empathy is in all layers of the upper pyramid above emotional recognition. This addresses the missing apex of Maslow's hierarchy. After the top of Maslow's hierarchy of self actualization, there needs to be self transcendence and emotional unity. So, Maslow's hierarchy of self actualization basically represents the highest level or stage in this model of human motivation, the hierarchy of needs. According to the hierarchy of needs, self actualization represents the highest order of motivations, which helps us drives us to realize a true potential and achieve an ideal self, and empathy is an important part of it. So there are three types of empathy: cognitive empathy, affective empathy, and somatic empathy. When it comes to AI and moving towards a more human like intelligence, empathy will definitely be essential, since human intelligence is different from AI, or artificial empathy is different from human empathy. Empathy can be learned, and AI can surely be equipped with empathy in the years to come. Also, it could be scary, however, if not used cautiously. Therefore, ethics and AI are also extremely important. Ethics and AI refer to a set of values or principles and techniques which employ widely accepted standards of right and wrong to guide moral conduct in the development and deployment of artificial intelligence technologies. So, I would like to go with uh, the biggest challenges in AI, which could be privacy, required computing power problems, and yeah, so these could be some biggest challenges in AI. And some trends could be automation, business analyzing their results in real time based on AI, explainable AI, NLP powered machine learning conversation, etc. And thank you so much for listening to me. And here are my contact details.